Hi everyone. Today we are going to look at conditional statements. In other words, branching statements. Condition uh, is defined in a dictionary. The state of something with regards to its appearance and quality of a working order. Therefore, in coding, if something it comes from the top, and at this point we can decide whether current state is true or false. If it true, then it goes to this branch. Whatever the result of that process, the evaluation is false, then it goes to the other the branch. That is like conditional statements in coding. The computer programming benefits us to determine with the values and therefore based upon the current states, it may make a decision. The result of that decision may give us some additional the branch to move in. So it could be true false type of branching, or it could be many different branches. Okay, so it looks like the conditional statements is if-else statements, basically. So if statements consider a condition, and this condition needs to be evaluated. By the way, there is if statements should end with the colon. And if this condition is true, then the very next code block, it could be one statements or maybe a long list of long sequence of the statements. Anyway, we call that action block. So if a condition is true, colon, then goes to the very next action block. Otherwise, if it is not true, then go to else part. In the else part, then there is another code block, which is for action 2. Depending upon this condition, if this condition returns true, then we do action 1. If this condition returns false, then we can take the action 2. This is very simple, the conditional statements. We can expand this if-else statements further and further. Not only true-false binary branching, but also depending upon these conditions. If this is true, then action 1, this is code block. If it is not true, then this is a combination of else and if. So together we call that elif. Elif condition 2, so we can evaluate another condition. If this condition is true, then goes to this action 2. Otherwise, go another elif and another elif and another elif. Finally, it goes into the else. Whatever the condition here, if this is not true, that is not true, and more and more and more elif statements. If everything is not true, then we can consider the else block. In the else, then we have also the action, another action block. So we can start with the predicates. So what is a predicate? In mathematics, predicate is a statement that gives us either true or false, that we can call the predicates. So we can compare, for example, hey, the age. If the age is greater than or equal to greater than or equal to 21, or less than or equal to 36. So any age in between 21 and 36, then it returns true, right? Otherwise, it returns false. So if it is predicate, it returns true or false, depending upon the states of data. So state of data, in this case, age, depending upon the real value. So value is given. Hey, my age is, for example, 29. Then according to this predicate, your age 29 is true, because this predicate says age should be greater than or equal to 21 or less than or equal to 36. This kind of expression has been was confused by some of the students because we have to rewrite this into two parts because this in computer only we take this the binary operator, which means we can take left side and right hand side. We can compare this operator compares this and that. So this is one predicate, and the other one is another predicate. Let's say this predicate returns true, the other predicate returns whatever that value is. Then we can logically combine those two. True and true, then it returns true. True and false, then anyway that is false, right? False and true, still false. False and false, of course false. That type of a logical connector, this logical connector connecting two predicates. Each predicate returns true or false. That type of things was the expression in typical language, programming languages. But we are lucky if we are working on Python, then Python still takes this kind of things. So mathematical expression can be taken in Python. So you don't have to worry about this. So it could be the conditions, the given variable operator value, what that is. It's a given variable, ag, and given value. So we compare variable and value, typically, right? Or variable and variable. Then two variables needs to be like here. Age is greater than 21, then this is a variable, this is a value. We have an operator. So that we can, this predicate tells us either false or true. When it comes to real value for this variable, then we can evaluate so that we may get the result, right? True or false. The other one is two variables, height and depth. This is variable, height, and depth is another variable. Here is an operator, but still we can evaluate this when it comes to the value assigned to the variable at each side, right? Lastly, variable itself is returns true or false. If this variable is, we call that Boolean values. Okay, Boolean value means the value itself tells us whether it is true or false. For example, red light. Is a red light? Then yes or no. That is the answer, right? So we don't, in this case, we don't need to use the logical operator like this, less than or greater than or logical operator. But itself, the why we need a logical operator here, in that way we can return true or false by comparing left side and right hand side, right? But in this case, by itself returns true or false. Red light, true. Red light, false, right? Itself returns true or false. This itself is perfect predicate because it gives us true or false. So with that predicate, we can now construct a conditional statements. Assuming that we have here using input function, enter your age in integer, then it gives us the data, right? By the way, we have an error, right? Whatever the user entered the value from your keyboard, that is the string. If we want to treat this data like an integer, therefore integer, look at this operator, then is data greater than or equal to 21, then this comparison, if this comparison is operated for integer, then the other side should be integer also, right? So data here, first of all, if we say int function only, then data itself is a string value. So don't forget to put here int, right? That is another 2-cent comment to you. So int and everything from there, and we can close here. Input should be inside here, int. Then when user enter the value from your keyboard, there is a integer keyboard, right? 1, 2, 3, 4 keyboard, whatever combination of those keyboard you can put there. Hey, 9, 1 and 9, then we assume that is 19, but your computer doesn't behave as you assume. You have to tell explicitly, hey, this is not 1, 9, but this should be 19. Then you need to put here integer function. Anyway, so data is greater than or equal to 21. Then depending upon user entered value, this predicate tells us either true or false, right? If this is true, then we can print you are already an adult. If it is not, then you are still a child. In what case we use this kind of decisions? If somebody comes to my liquor store and asking the alcohol, then I can say, what is your age? Show me your ID. Then depending upon the age of that customer, we can determine whether we are able to sell the liquor, alcohol, right? Similar things has been discussed in earlier homework assignments, right? There, we didn't simply say this, but we can simply return data, or we can print data. The age, user enter the age is greater than or equal to 21. Then it gives us true or false because, yeah. Okay. So we call this is a logical connector, and this separately we call that the predicate conditions, right? And this is the if part, and this is the otherwise else part. We have a comparison operator, equal, or greater than equal. Yeah, those things indicated here on this slide. And also we can expand our if-else statements further. All right, this is conditional statements. So I can close this, and I will bring up another one. Why we are trying to use the conditional statements and iterative statements together? you will see if I bring an example that the, with the conditional statements and iterative statements together, then it can make a little bit more the real world examples meaningful. We can handle the examples more effectively, and that may make sense, a lot more sense. So I want to jump in. We don't learn whole a lot of the iterative statements, but I want to simply one step in this iterative statements. This is a new world. So once we know the conditional statements, now, hey, let's get into the iterative statements. See how much that we can make our the coding skills more effectively and more meaningfully. So iteration is really important in coding. For example, if you make a grading rules, so we can apply the grading rules for one students. But if we have 100 students, then I want to apply the same grading rule to each of the students in my class. So that is the iteration. I want to repeat the same rule, apply the same rule to all the students. That is an iterations, right? That happens all the time. And that is the reason that we want to build, we want to the code to handle massive data, the data that we want to handle, that we have to handle, then I don't want to do, for example, millions and billions of data manually. The consideration at a time, then I need to do that the same thing for a billion times. But if I could do one thing in more clear way, then I can code it. Therefore, my program, my codes can repeat whatever the number of times. The iteration is great, the benefit to us. Once I know how to do manually one time, then I can code it, and my program can handle it billion times per day, and next day again billion times, and can do each day endlessly. That is whole purpose that we will do. Okay, so so I'm going to come back this iterative statements next week, but I will, instead of doing further, I want to do the Google Colab. Okay. If those who do not know how to bring your Google Colab onto, here's this way. If you do not know how to bring up IPYNB file to Google Colab, then let me repeat one more time. From your homework, from your Blackboard, there is a I believe that is somewhere here. If I can show that to you, give me a second. Because I am surprising some students still do not know how to do. Therefore, I keep repeating this. Please make sure that you know at least once. If you know, for example, here IPYNB, this is the file. If you click this, then you can save it on your laptop. Okay, so you need to download IPYNB file from Blackboard. thing is this: your Blackboard, that is a cloud system. Here, Google Colab, that is another cloud system. And your laptop is the computing device on your hand. So your laptop is kind of a bridge between one side cloud server, which is Blackboard, to another cloud server, which is Google Colab. Okay, so download IPYNB onto your laptop, and when it comes to this Google Colab, which is colab.research.google.com, then you can bring it here file. Then there is a upload notebook, browse, so that you can choose that file that you downloaded from your Blackboard. That way you can bring up onto your Google Colab. Then you can see this is very, very neat and handy, because it is a combination of text and your codings. And for coding, you can the execution is very, very simple. You can simply click it, and you can code on that code block quickly, and you can test it by clicking the button to execute. So very, very handy. Another big thing is that this is hassle-free. You don't have to worry about any installations, any systematic issues that may take place on your laptop. Here is a web-based, so no worry. Okay. Only thing that you have to worry is you are working on the cloud. The files, of course, that is not on your laptop. So you have to, again, when you complete this, then you have to download it. Okay. There are two ways that you can download. Here, download in this IPYNB format. IPYNB format. If you want to submit IPYNB, it cannot evaluate at my side. So you have to download it .py format. Okay, once you have .py formats, it gives us everything here, text and coding list, everything can be converted to .py. Homeworks is only the small portion of the coding list. Here's the coding list. There are many coding lists here, code blocks, but only the one that I ask you to submit here is a homework assignments. This is only that I ask you to do. Okay, so you have to submit only here on this part. There's a code number 3.1, and then see here, if, and then I ask you to write something. So you have to fill in the code blocks, make this code block complete, and make sure this code is executable. Then you have to submit this. I wanted to submit only homework number 1 here and homework number 2 here, right? Today, only 2 homeworks. Each day you will have 2 homeworks, basically. Okay, so conditional statements. So we looked at the predicates, right? So this is a predicates. It gives us a true or false. I want to take this all comment so that I can run this. Then it tells me true or false. It says true. Of course, the 5 is greater than 3. So that is true, right? So, and then we can give this back. Consider the list. This is a list 4, 8, 23, 9. And for example, if we say print, I want to make these comments out and I want to run this. So we have here 1, and this gives us, this is a predicate, so it tells us whether it is a true or false. And this is a list, so we define a list. And from this list, what is the second element? By giving the index 1, which is the second element. Second element in this list is number 8. So this is the predicate because we have double equal sign. Single equal sign means that is an assignment like this, right? So right hand side needs to be assigned to left hand side. If we have a double equal sign, it means I want to check whether it is true. Double equal sign checks the equality. Okay, so left hand side and right hand side can be compared to see if they are the same. If they are the same, then entire this predicate gives us true. Otherwise, it gives us false, right? Let's see. This is a false, right? Number 8 here. So if I run this, then false. It gives me false. But if I say here, instead of this index, if I say 0, then it should give me true because the first element in the list is 4, and the right side of this, the equality check operator is also number 4, so it should be true, right? So it gives us true. That's what it is. Same thing we can see here. This is the third element. So the third element is a 23. So what is the maximum from this list? That is also 23. Here, the third element is greater than maximum. They are the same, right? It is not greater than. So it should be false. The second print statement should be false, right? It should be the false. But if I put here greater than or equal sign, it gives me true, right? It gives me true. But this gives me false. One more thing here. Length of the list. What is the length? What is the size of this list? How many elements in the list? That is a len, right? So 1, 2, 3, 4. 4 elements. Is 4 greater than or equal to 4? Like we looked at in the previous example. Yes, it is, right? So true, false, true. The lastly, here, list dot index. Index is gives us the number of index if we give the element, one of the element. So it says 9. 9 is in this list. Therefore, it gives me the index. What is the index? That points to the position where the number 9 is posted. That is the fourth one, which is index 3. So in this case, that gives me true, right? If we put here 8, what is the index number 8 for the value 8? Then that should be 1. So in this case, that's the last one here should be false. False. What if I put here number 18, which is not there, right? So what happens with that? Then it gives me an error because 18 is not available here, right? It gives me an error. Okay. So next, more predicates. So what is the type of list? LST. I want to clear that. What is the type of list? I want to, consider Boolean values. Okay. So list, can we append? List is number 4, number 8, number 23, number 8, right? That is the list called the LST. To that LST, I want to append true is the value. This itself is a value. It's not a string true, right? If we say true, true, then that is a string true. Simply true means this itself is a value. Okay? This is a reserved word. So this is like number one, number two. This is a value. You don't need to evaluate it. If you say true, then you have to evaluate it. For example, see, this guy says, oh, don't use true, because that is already, we know that, right? But anyway, so by having this, I want to comment this and run. The first I want to append the true, so true comes here. It's not like LST append true. If I say this, then this is, I keep saying this, right? So I want to do this once. Clear that. I want to do this one time, so that append to true. Therefore, I have true with no the quote. If we have a quote, it means that is a string, right? So true is itself is a value. False itself is a value. Okay. So, and if you want to append the string quote and unquote true, then you have to do so like this. Okay. Here, if you want to find the last ones, then it gives me true. If you want to give me the second last, then it gives me false. If you want to do again the third from the back end, then you will have true, right? But oh, I returned so many because this keep appending. So reset the list, and if I do this, then it returns like this. More predicates. What is the type of LST? Of course, then that is list, right? And we can also make is instance. That is, this is a function itself tells us whether it's true or false. Is instance is a function. Okay. For example, here Python is instance. Then you can see there is a function is instance. Built-in function is instance. So is instance compare the first argument is the instance. Second argument is a type. Is 5 an integer? That's what it is, right? Similarly here, is LST a list? Is LST tuple? Is LST dictionary? But clearly, because we defined LST is a list, only this one gives us true and all others false, right? So only this one is true and the last two are false because LST is a list. Conditional statements can be formed in this way. If predicate and action, or if predicate 1, action 1, else if predicate 2, accordingly action 2, and else action. So as we looked at in the earlier homework assignments, can I buy alcohol, enter your age, then if I say 11 years old, then false, right? Of course. If we run that again, then if I say 22, then true, because alcohol, the eligibility for alcohol buying is the age 21 or older. We used in this case the predicate only, right? This is a predicate. We can expand this predicate using conditional statements. If age is greater than or equal to 21, then we explain further. Otherwise, explain the other. Same thing can be done differently, right? Here we simply use the predicates because the predicate returns true or false. We print true or false. In this case, more explanations. Same thing, but more explanation. 22, then it says, yes, you can, right? We can consider another list, LST. If length of LST is less than 5, if number of element is less than 5, then we want to append the small one back, and we can say increased. Otherwise, if this is number of this is greater than 5, then we pop the last ones, and therefore size of this list can be decreased. Okay, look at that. Take a moment and see how it works. This is if, and then we have a predicates. This is predicates. This guy tells us either true or false. If true, then we can add the first element into back end. Otherwise, we want to take the back end out. Okay. I know this. What does this mean? Not really something applicable, but right now, but may or may not applicable. But some cases, yes, you can. But simply, let's assume this is the logic. Then, if it is the case, then how can we code it? That is the case here. So we can do here. The last element is popped out, right? Because we the size of this is less than, no, it's not less than 5, which means else part. So the last one popped out. So we say decrease and that. So if we take this and back here, put that back here and rerun, then still decreased. 7, take that out, right? We can copy this and push it back and rerun this. Then, because this is already, the size of this is less than 5, then rather than pop the last one out, we want the first one, the first element can be attended to the end of this list. So it'll be 4 and still 9 remains. And then this number 4 can be coming back there. So if we do this again here, then, oops. And if we run this, then because this is 1, 2, 3, 4, 5, it is not less than 5. This is 5, right? Therefore, the last one popped out. So 4, 8, 23, 9. So again, if we do coming back here and then rerun, then number 4 comes here. So we can do this manually, right? I showed this manually. This manual, the repetition can be done in coding. Therefore, we looked at iterative statements. In Python, 2 kinds of iterations. Oops. For or while. Okay, 2 kinds of iterations. So let's look at for. let's say assume we start with the sum. I want to count, okay? Count from 5 to 20, every other number. I call it, this is a for loop. For I is a current variable here. In is a reserved word following some container, some collection. So range is a collection. Okay. So what is a range? If you go here, Python, range is a function, so you can see what it is. Say here, so range function, that is also built-in function. So definition of range function returns a sequence of numbers starting from 0 if we don't say anything, like this 6. If we have only one arguments, then it starts from 0 by default, in increment by 1. If we have 3 arguments, then the third argument is the increment. But because you have only one number, then first element and third element, first arguments and third arguments are missing. Only the second arguments remains. If you state only one, which means you assume it counts from 0 and increment is 1, and it stops the specified number. It stops before the specified number. So it stops before number 6. So what it is that X is range 6. This itself is, let's go back here. For example, I want to code here. Let's say range 6 and hit enter. Then it gives me 0 and 6, right? So let's say X equals range 6, and then if I say print X, see what happens. There's just still 0 and 6. We don't say, so what is the range 0 and 6? It means in order to get it, we can simply say print I in X, and then print I, then we can say what it is. Oops, not print. For I in X, then we can see. So range is 0, so it's starting from 0. 0, 1, 2, 3, 4, 5, 6, but it should stop just before this number 6. So this is a minimum number, this is maximum number, but maximum number is not included. Okay, excluding the last number, this is a maximum, this is a minimum. Then that is 0 to 5. That's what this range means. Therefore, let's say in this case, this 5, the first, this range has 3 arguments, right? The first argument, if we have only one argument, then this is the same as one argument is 0, and then third argument is 1 by default. So you don't need to say 0, you don't need to say 1, only 6 in this case. Anyway, that remains the same. Should be the same, right? You can omit 2 arguments. That's still the same. You can omit because there's a default number still the same, right? Other than that, if you say I want to start it from 1, then not starting from 0, but 1, 2, 3, 4, 5. Look at that, right? And again, hey, I want to take every other number. Then you need to say increment by 2, then 1, skip 2 and 3, skip 4 and 5. That's what it is, right? That is exactly the same thing here. So we can say that is, I want to add all the numbers starting from 5, every other number till 20, but I want to stop just before 20. Okay. That is this for loop for this iteration. I is how many times I is iterated. That is, I do not know how many times, but you can count like this, then how many? Like this, for example, 5 and 20, how many iterations? So 1, 2, 3, 4, 5, 6, 7, 8. 8 times, 8 iterations, right? At each one, initially, the first iterations, number 5. So number 5 is added to sum. Here in this case, if we have a plus and equal sign means I would say sum equals I means sum equals sum plus 1. Don't think this in mathematics. This is not true in mathematics, right? But this equal sign is an assignment. When it comes to this assignment, then you have to evaluate the right-hand side. So sum plus 1 needs to be evaluated. Whatever result of this computation, result will be assigned to the left side. Okay? That's what it is. Sum plus equal I means sum equals sum plus 1. So at very first time, sum is 0. Right? Sum is 0. Sum never changes when it comes to up until these statements. So sum is 0. I is initially, here in this case, number 5, right? So it should be number 5. Oh, it's not I. It's number. So at the first, sum equals sum plus, at the very first time, I equals number 5, right? That is a 5. Right-hand side needs to be evaluated. What is the current sum? Sum never changes from this, the beginning of this code till this time. Sum is now 0, right? It means sum is nothing but 0. 0 plus 5. So right-hand side sum is 0, and we add, therefore the result is 5. So left-hand side sum will become 5, because this will assign to left side. So first sum value will be 5. 5, right? This is the iteration from here there. That is the iteration. So we need to go back. What is the next I? Next I is 7, right? So we need to come here, 7. I will become 7. Like here it's nothing but, it's not 5, it'll be 7. So let's say at second iteration, sum equals sum plus I, but the second I is 7 here, right? So it'll be 7. What is the second sum? Second sum is whatever the sum after the first iteration. which is 5 here, right? So it'll be 5. 5 plus 7 equals 12. So the second sum will be 12, right? Keep going like that. So if we print sum here, then we may be able to see that clearly. The very first here for loop I in this range, right? That range. And then I want to, this plus sum is nothing but that. So I can spell this out. Plus, that's fine. I can rerun. Anyway, same. Anyway, they are the same. So at the very first, sum equals 0 plus 5. So when I want to print the first print, then number 5. And then at second iteration, this number 5 will be sum here, right? Because I print the sum. When I come back here, left side sum will be 5. So 5 plus 7, that is 12. It goes for like that. So here again, at the third iteration, sum equals the previous sum plus current I. Current I is 1, 2, 3. Current I is 9. So it'll be 9. Previous sum is here 12. So we need to have 12. So 12 plus 9 equal that assigned to sum. So current sum will be the addition of these two, which is 21 here, right? It goes again and again. I will re-explain this next week, okay? But I want you to think of this. But I want to give you some, the first homework assignments. Yeah, I think I need to give you, anyway, here, the first homework assignments, okay. So this goes like this. And I want to make this more the same ones as before, but rather than simply print I here, what that means here, I want to put I here, I and sum. I want to print I and sum. Initially 5, so sum will be 5, and 5 and the next I, so 5 and 7, then 5 plus 7, then is 12. And again, next I is 9, so previous sum is 12. So 12 plus 9, then there's 21. The next one is I will become 11. The previous sum is 21. So 21 plus 11, that is a 32. We continue to that like this. Then that's 47. 45 plus 15, that is a 60. 60 plus 17, then that is a 77. 77 plus 19, that is a 96. So finally, the sum is 96. That's what we would have here, right? Now, is there anything that I can print everything like this? I want to 5 plus 7 plus 9. I want to put them in one like equation. So 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. That's what I want to do here. In coding, I want to add from 5 to 19. I want to add from 5 to 9. I want to add all the numbers, every other numbers from 5 to 19. That's exactly what it is. I want to make a formula. So I want to write everything in one word, one sentence, not like this, every other sentence. Each print statements for each line. Even if I do print, I want to continue to print remaining on the same line like this. Then you have to do here end. Okay. So let me show to you the explanation of print statements. So print, then come back here. It says print statements has somehow and equal the option. So we have an option here, and optional, specify what to print at the end. By default, it'll be line feed. By default. If you do not say anything about end equal, then next line. But if we say end equal, then rather than the next line remains the same line, but you have to write that, whatever with that string. That's what it is. So without instead of new lines, after 5 instead of new lines, I want to put plus sign. So after 5, plus sign. After 7, plus sign. After 9, plus sign. That's what it is, right? If we put here, for example, 20, then you can see, oh, how long does it do? I want to put that, comment it and see every other number from 5 to 200, but exclude 200. I want to print that number, but without having to the next line at the end of this 5, I want to add plus sign 5. At the end of 7, I want to add plus sign. That's what it is, all the way to here. So 199. At the end of this, then we put plus sign. Plus sign. Okay, so what I want to do here, at the end of this, instead of this plus sign, I want to put equal sign, and then equal, and then the total sum will be returned. I want to look at here, this print and sum, this is code block, right? This for loop and colon, that affects everything with that indentation. 2 lines in that code block. 2 lines is for loop, body of the for loop. 2 lines of this summation and the print statements repeated for how many times? Whatever the number of times, starting from 5, every other number until 20, right? After we do this, after you do this, then next statements of this for loop is print statements. So this sum is the total sum, the final sum. So when I run this, then up to here, that comes from this for loop. And at the end, finally, we print the sum. That is 96, right? That is 96 is the last sum. My question here, can we put here, instead of a plus sign, I want to put there equal sign. That is homework number 31. What should you do? you need to see whether it is a final number. Then you need to say put equal sign other than plus sign. Okay, you want to do this plus sign, but when it comes to the last number, if it is a 19, then you still add. If it is greater than 19, then instead of this plus sign, I want to put equal sign. Can you make it? So you have here if some condition, then you need to do equal sign. This is the description for the final here. Other than that, you keep adding plus sign on the same line. That is the first homework assignment. Okay, next one is draw a tree. It's another expression, exercise of the iterations. I want to execute this first anyway. Like this, like a Christmas tree. This is one for loop. I in range 1 to 13. So from 1, and then 13, whatever this line of, how many lines from 1 to 12? Let me count the number of lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 lines. So how many? So this for loop, this is the body of the for loop, right? This body gives us one line. One line, okay? So for each line, I want to do this. What I want to do that, let's do this. If we have a print, let's say star, and then if you do print, then you print one star, right? But if we want to do print star times 2, star times 3, star times 4, star times 5, then it gives me star, 2 star, 3 star, 4 star, 5 star. 1 star, I think in the army, 1 star means brigadier general. 2 star maybe major general. 3 star lieutenant general. 4 star is general. 5 star is the president, right? In the military. Anyway, so we need to print stars. This is very similar to we want to make a star. But if we do this, then somehow we want to make some space, right? First line, for example. Then from here, I make white space and then 1 star. And next line, from left end, a number of white space and then 3 stars. Every other stars, right? So this star plus I times 2 minus 1 means, I'll make it step by step. So for I in range, for example, 10, okay? Then if I want to print a star, how many stars? I want to print I times, then make this, right? But I want to make 1 line the first line 1 star, second line 3 star. So each lines I want to make a odd number rather than odd number, even number, odd number, even number, right? In order to make this odd number, even number, then we need to make this times 2 and minus 1, then that'll be odd number and even number, right? So if I make this, then the first line 1 star, second line 3 star, 5 star, 7 star, so every others. That's what it is, right? I times 2 and then minus 1, then it jumps every other 2. If you jump every, if you want to make double, then I plus 2, I times 2, then 2, 4, 6, 8, 10, like that. But we want to make a 1 less than this. Therefore, we want to make minus 1. Then it'll be 1, 3, 5, 7. Okay. And then I want to make a space, print a space, and then let's say 10 minus I. So I want to make here, I want to make space, but that space, how many space that we want to make? 10 minus I. So if I is smaller, which means the first line, then I want to make more space. As I grows, the white space will be reduced. So that's what it is. Starting from 10, I want to reduce as I grows. More spaces on the left. So if I click this, then it'll come like this. That's exactly what we have here, right? So the upper triangle is done, right? Very simple ways. And then the bottom, the trunk, that is also another for loop. For I in range, let's say 3. Then I want to print, let's say star times 3. Then this 3, 3, 3, 3, 3. That's exactly what it is, right? But I want to make a space before this. How many spaces that we want to do? Let's say 8 spaces. Then you can do, I want to make 8 spaces. So space times 8, that is the first element of this print. So I want to make space first, 8 spaces, followed by 3 star. That's what it is. So I have 8 spaces and the 3 star. Next line. I do not have any I here, right? So it is not increase, it is not decrease, but this I tells us how many times of this. So I want to make whatever 3 times. Same stars, same space, exact same ones, but 3 times. That's what it is for. Yeah. So I combine these two. Combination of this and that is this. So total 12 lines till I is 9. Okay, from 1 to 9, 9 lines. So 9 lines. I want to make this the upper triangle. This is upper triangle. No, this is upper triangle. This is the. This is a lower rectangle, right? This is a lower rectangle. This is upper triangle. So I will demonstrate the upper triangle and lower rectangle. Combine these two. So for because how many lines that we have? 12 lines. So from 1 to 13. If it is greater than 10, then we do this. Other than that, triangle. Okay. Or you can do, for example, if less than 10, then you can make this here. So, this is this means this means a lower rectangle. This is a upper triangle. So if I is less than 10, up to 10, then we want to make a triangle. Else, the bottom, lower rectangle. This may be a little better for you to understand, right? So up to 10 means 10 is not included, right? So that much we do triangle, and then lower parts rectangle. So if we run this, then same thing like this. Okay. Homework number 32 is I want to generalize this. Let's say if we put enter two numbers, for example 10 and 3, but if we put 20 and 3, then first number is for the triangles. How many how many depth of the triangles, and then 3 means this. How many lines of a rectangle? How many lines of a triangle? Okay, but depending upon this, the first number. This includes a little bit of the algorithmic thinkings. Remember the previous, how many lines that we skip? We skip from 10, here in this case, from 10, I want to reduce I is increased. So given number, I want to, if this is 20, then more white spaces, right? 20. And 3, then we need to make sure that's a center, so that 3 lines of, the thickness of this trunk remains the same, only 3 stars, but how tall that trunk is, how tall this the triangle is. Okay, so for example, if we put 50 and 50, then it goes this and 50 this long. Okay, code will be like this. I want you to put something here. Okay, think about some of the algorithmic thinking. So take the usual 2 numbers. So we split the 2 numbers, and first number is the size, second number trunk, and we convert into integer, because the 2 numbers, whatever number that you want enter, that will be treated in the string. So you want to convert it to integer. And then this code very similar to the above. So I want you to modify a little bit of the above and draw the tree depending upon the number that you have. Okay, a little bit intelligent coding here. Extra. I don't give you any homework assignments. I want you to click this. What happens? I want to make it a little bit of the circle, but it's not real circle, but a little bit. So I'm not going to make you confused. But only those who are interested in try to run this. If you run this, then make a little bit of the circles and see how this algorithm's defined. There's a definitions. So this is something about the function. It's too early, right? But this is extra. I'm not going to explain this to you, but okay, this is the end of today's lecture. So we have two homework assignments, 3.1 and 3.2. Okay. I want to weigh 3.1 more. 3.2, this is a little bit of extra. 3.2. Well, I want to make it equal, so 50-50. So make two codes, 3.1 and 3.2 for the homework assignments for today. All right. I'll see you next